Hi, I'm Dhruv. Today I'm demonstrating the self-improving prompt optimization API. So here, let's say someone have a task in hand to do a sentiment analysis using LLM. So basically, rather than just giving a simple prompt such as classify this text, we will first of all uh, generate a synthetic data set or any data set that we have regarding that particular task. So for example, here I already generated some examples. For example, sentiment classification, intent detection, and etc. So sentiment analysis. Here, dataset name is sentiment analysis, and this is my sample CSV data, which I already embedded in the particular workflow. So if you see the data set, it's very simple. There are only two columns, text and sentiment. Text says I absolutely love this product, best purchase ever, and if you and it has a label of positive sentiment. So we will first of all upload this data set. To hold this data set, I have used something called a pixel table. So the Pixel table is AI native database for versioning datasets and prompts with computed columns. So it's very easy to maintain in this kind of scenarios. So I will upload this dataset first of all. Okay, after uploading the data set, I will write whatever the prompt I have in my mind. It so basically we are optimizing a prompt, so we can just put anything that we want uh, uh, LLM to do in our words, and then our system will optimize it. So basically for this task, as we are doing sentiment analysis, I am just putting a simple prompt like classify the sentiment of text. And here text is a variable which will embed the user text. Description is just classify this text positive, negative, or neutral. And I'm creating this prompt. Once I create this prompt, so here for optimization, I have used something called teacher-student distillation. So I have used a massive model of 70 billion parameters to optimize a prompt for a smaller, faster model, which is 8 billion parameters. So why I use it? So production inference on 70 billion is so expensive as well as slow. So the trick is that the 70 billion model's reasoning is distilled into the few shot example of a 8 billion models prompt. The 8 billion model is effective, and it's like a reads the mind of a 70 billion model in a runtime. So which is also time saving and cost saving. So when I will click start optimization, it will it will create a one Celery job, so which will process the prompt in a background and try to optimize it with the help of a 70 billion parameter model. So I started the job. Here you can see there was a progress bar, and now we see that our prompt is 100% optimized. So basically, this is our old prompt which says classify the sentiment of a given text. But our our optimization algorithm changed that particular text to classify text as positive, negative, and neutral. That's good. As well as is it also generated few shots example, because we know that a smaller LLM always works better if we give it a more context, such as few shots example. So here I have also used DSPy, which is DSPy, which is a declarative self-improving Python library for prompt engineering. So in DSPy, we have multiple optimization algorithm for a prompt, such as MIPRO, Bootstrap. So over here, I have used Bootstrap. So how it works, we just feed the training input to a teacher model using that, and it attempts to solve them. If it succeeds or passes the metric, we save the traces. As a result, we build a library of golden examples where we know the reasoning, which reasoning leads to the correct answer. So here, this is a Redis. You can see that Celery task force succeed, and that's it. Thank you.